The other thing that you need to understand about the mole is that 1 mole value of 1 mole is equal to number of atoms, number of carbon atoms present in 12.01 grams of carbon sample. Okay, so 1 mole of atoms, so the number of atoms, number of carbon atoms present in 12.01 grams of carbon is equal to 1 mole. So 12.01 grams of carbon contains 6.023 times 10 raised to 23. Now, if there were 36 eggs in a box, how many dozens of eggs would that be? That would be 3 dozen eggs. Right? A similar question can be asked in terms of molecules and atoms. If a sample contains 1.2 moles of sodium, for example, how many sodium atoms is that? Right? So 1.2 moles of sodium. Remember, 1 mole of something, in this case the something is sodium atoms, is 6.023 times 10 raised to 23 sodium atoms. Right? So 1 mole of sodium atoms, 1.2 moles of sodium atoms. So moles of sodium atoms and moles of sodium atoms cancel out, and we end up with 7.2 times 10 raised to 23 sodium atoms. Another that can be asked would be how many molecules, for example, how many molecules are present in 0.893 moles of oxygen molecules. So the sample that you have, it has oxygen molecules, right? And I'm saying oxygen molecules, and I'm making sure there are oxygen molecules and not oxygen atoms. Okay, O2. Okay, how many molecules are in this one? So 0.893 moles of oxygen molecules, right? And since I'm writing O2, I don't have to write O2 molecules. It is implied, since it is O2, it is molecule. So 1 mole of O2 has 6.023 times 10 raised to 23 oxygen molecules, which will turn out to be 5.38 times 10 raised to 23 oxygen molecules. That was the conversion from atoms or molecules. Okay, it could be anything, atoms or molecules, to mole. Now, we also need to know how to convert from and to grams. Okay, so this is to count atoms by weighing them. Okay, so how do you do this? There are many, there is step-by-step process to that. First of all, we need to know how to calculate molar mass or molecular weight. Okay, what is this first? So we have to understand this first, and then we will get into counting atoms by weighing them. Oxygen, on the periodic table it says it is 16 AMU. What does that mean? This means that one little atom, that one individual atom of oxygen has a mass of 16.00 AMU. It exists as O2, right? So then the mass of the oxygen molecule is 32 AMU. Okay, now in a box or in a container, if we have one oxygen molecule, the mass of that sample is 32. If we have two oxygen molecules, the mass of that sample will be 64. If we have three molecules of oxygen, the mass will be 96. Okay, so these are these little molecules and little atoms, right? Keep in mind, you cannot see them. Okay, they are not visible to us, to the naked eye, individual molecules. You see the whole sample. So instead of 1 or 2 or 3, let us suppose that there are 6.023 times 10 raised to 23 oxygen molecules. Okay, this is a huge number, you have to remember that. Okay, so if there are so many molecules of oxygen present, we will say the sample contains 1 mole of oxygen molecules, right? Yes, pause the video and understand that for a minute. Then we want to know what is the mass of this sample. What is the mass of this sample in grams? Okay, understand the question one more time. There is a sample of oxygen that contains 6.023 times 10 raised to 23 oxygen molecules. We want to know the mass of that sample in grams. So how are we going to go there? So we're going to say 6.023 times 10 raised to 23 oxygen molecules one oxygen molecule has a mass of 32 AMU, right? So this will give us the mass of 1 mole of oxygen molecules. But I don't want the answer in AMU. We want the answer in grams. So I will add another component to that. One more conversion factor to that, and I will say that 1 AMU is, now I'm giving the extended version of that conversion factor. Previously I said it's 1.66 times 10 raised to negative 24. Now I'm going more significant figures, and I will tell you that why I'm doing that in just a minute. 1.6605386 times 10 raised to negative 24, which will turn out to be 32.00 grams. So what do you understand from here? One atom of, or when one molecule of oxygen has a mass of 32 AMU, 1 mole of such oxygen molecules will have a mass of 32.00 grams. So 32.00 is the mass of 1 mole of oxygen molecule. So we'll say molar mass of oxygen or mass of oxygen is 32.00 grams per mole, usually written as 32.00 gram per mole. Okay, so please go over this video many times to understand the connection between mole, mass and number of items. So then, if we had to make the whole concept of this video into one triangle, we will say 1 mole has the same mass as molar mass. My arrow was very long here. Molar mass, it has the same mass as molar mass. And 1 mole has 6.023 times 10 raised to 23 items. So we can safely say that 1 mole of a species will have 6.023 times 10 raised to 23 items, and the mass of that sample will be equal to molar mass. So a conversion factor, say for example in terms of oxygen, could be 1 mole of oxygen atom has a mass of 32 grams. Of nitrogen on the periodic table, it is 14.01 AMU. So N2, nitrogen exists as N2. Mass is 28.02 AMU. So molar mass or molecular weight for nitrogen would be 28.02 gram per mole. So our conversion factor, if we had to do some conversions, it would be 1 mole of nitrogen molecules is having a mass of 28.02 grams.